Can you see my screen?
Yeah.
Yeah, so my project is an AI-driven employee attrition predictor. So yeah, I'm gonna explain step by step the process that I followed for this project, and then at the end I will give you a demo of the application working.
Yeah, that's good. Just give me a walkthrough of the presentation, and we can then switch to the demo.
Yeah, yeah. So let's start with the problem. So why we're doing this project. So according to my research, attrition costs more than half of the employee's annual salary, which includes recruiting, onboarding, lost productivity, and existing HR analytics rely on salary-based rules. Therefore, there are no warnings before an employee resigns, and employees have skipped a huge amount of meetings and they've not responded to emails, which is a big factor for them resigning. And these factors often appear months before resignation, but they often go unnoticed by companies and businesses. So therefore, our solution is an AI-powered multi-model model that integrates structured HR data, so tenure, performance, other factors like that, data about behavioral activity, so meeting attendance, work patterns, response times, test sentiments such as whether they show frustration or happiness, and overall goal is to predict attrition a few months in advance so that companies can do whatever they can to try and retain their employees before it's too late. So the reason this impacts us today is because it helps companies realize whether an employee is on the verge of resigning or not based on their behaviors and patterns, and it signals to them whether they need to take action or whether that employee is fine. And this also improves employee experience via proactive career and wellness support. And 30 to 50% reduction. There's 30 to 50% reduction in unexpected resignations, so up to half of the employees. And this also impacts us because businesses can retain top talent more easily, which leads to other sort of impacts. So our competitive advantage is that this combines structured behavioral and emotional signals, which is often not seen anywhere else. Managers and companies have evidence to see why an employee probably wants to leave or stay with this project. And these departments actively seek this. It's one of the more in-demand applications in real-world enterprise environments. Predicting attrition early, it reduces the turnover also reduces the turnover costs by forcing retention sources efficiently, and which also leads to more experienced group of people that can work together for a long time. So the team is definitely more experienced then, and there's less chance that um, that the team can run into some problems. So now let's dive into the first step of our project, which is getting our data set. So the data set I got is from Kaggle. It's a very as you probably know, it's a very common website where you can find very useful data. And a little bit about our data, there are 35 different columns, so 35 different features. And our target feature is attrition, which means that's the factor that is our dependent feature that is gonna be affected by our independent features, which are the other 34 columns. So for example, age, department, business travel, education, much more. And this is a side note for later. Our goal was to choose the most important features that affect the outcome, typically the most for our model to predict. So here we have kind of like what this here we have a screenshot of what our data looks like for these few columns. Uh, Please note that this is not the full data set. There are many more columns, but this is what it looks like for the first 510. So after we got our after we added our data set to the project, we began our exploratory data analysis, or EDA. So the first step here is we need to figure out what modules or what libraries we need to import from Python. So like the AI and machine learning related and as well as the data related libraries. So for example, here we have to import pandas and NumPy. So pandas is a very useful library for data manipulation, loading, and creation. You can even create your own data set using pandas. NumPy is for matrix and array manipulations. Matplotlib and Seaborn are both for graphing and visualizing your data. So it helps us understand trends with our data, which help us find some common patterns with our data as well. And scikit-learn is where we get our models and ML functions and algorithms from. So that's where we get the functions for training our data, testing our data, choosing which model we want to use, evaluating our model, etc. So our next step after we import the libraries is to clean up our data and make it ready for us to use for in our model. So in this code, we are making sure we don't have any duplicates in our data. And this this is for above. And here we're replacing the duplicate values with the mean of essentially. So that we get more accurate data. So then our next step is to remove outliers from our data set, because typically many models are sensitive to outliers, so that can impact accuracy and model performance. And they distort mean and standard deviation, which typically causes some bias to appear in models. And over here in this code, I used the IQR method of filtering out the outliers. There are many different other methods you can use. I just chose this one. So next step was to choose the our most important features that directly affect attrition more than the others. And I'll and this graph helped us realize those most important features. So when we train our model, basically we can only give it a certain number of columns to look at and analyze. Otherwise, our model can often be overfitted, which means it can understand the data too well, that it does not do well. It does not fare well with our testing data, and it can be a bit inaccurate. So in our code, we decided to choose the
Siddhant,
yeah.
how did you choose which features were the most what you call important?
Yeah, so I'm explaining that right now. I use I'm explaining the algorithm that I use to figure that out using the importance score. It'll be explained here.
Okay.
Yeah. So in our code, we decided to use to choose the top 10 features that affect the attrition the most, and as well, and display the graph as well using the random forest classifier. So over here, we figured out the most important features according to our random forest classifier was monthly income, age, total working years, the hourly rate, the daily rate, the years at company, the monthly rate, distance from home, employee numbers, and the number of companies that employees worked. So now that we know that the most important features, now we know, yeah.
No, so it was not clear. How did you get to the random forest? Like what? Explain to me the random forest classifier and what did you use to get filter out? How did you filter out the remaining columns?
Uh, okay, so over here you can see my code, right?
Yeah.
So uh, yeah, sorry, 1 second. Yeah, so over here I just like use like these different libraries and these target features to over here decide the like the top 10 important features using this function over here, pd dot series, which basically sorts the importances over here, and then using this specific code over here, which helps us understand the top 10 values. And
What
this
what
code,
is the what is the PD, like what is the importance based on? I'm trying to get what is the importance based on?
oh,
Yeah.
based on how it affects the our target feature the most, which is attrition, based on
Okay.
how it
Like,
the
but
most.
what is the status? What is the statistic? Is it covariance? It is principal component analysis? Is it what is the mathematical? What is behind like what does that like the importance thing you showed me? What is that doing behind the scene?
It's based on accuracy score. So this is basically what's the importance is based on.
The accuracy score.
Yes.
Okay. All right. I think we'll look at it later on. We can carry on for now.
Yeah, I was actually waiting for you to finish the explanation. I had a question too.
Yeah.
That you mentioned that you use linear regression and random
No, not
forest.
linear regression, logistic regression.
Yeah, okay, sorry. Logistic regression and or even random forest classifier.
Yeah, just to see the top 10 features.
Uh, can you explain for what reason did you exactly use random forest classifier and for what did you use the logistic regression?
Yeah, so here I used random forest classifier just to see just for the to see the top 10 features over here,
Okay.
right? And logistic regression I didn't use until later, until when I was experimenting with the model. So when I was deciding to choose which model to use, I'll get to that later though. So for now I just use random forest.
Okay.
Yeah. Yeah, wait. I explained this side. So since we found out now the most important features that affect attrition, then we need to remove the rest of the columns because they don't really matter as much
Uh,
to the model. Yeah.
okay, Sidhan, yeah, I would like to know actual the overall implementation of this because I don't want to look at the implementation very line by line. I would like to know in a gist that how did you implement it and the demonstration.
The implementation of what?
Yeah, means how did you implement this? I want to know about your understanding. How did you implement this? Because I know I can look at the code, but I want you to. I want to know how did you understand this, and I want to know how did you implement this.
So wait, how do I understand what?
The overall implementation of this, like we just explained that you use logistic regression later on. So I would just want to go through that. I don't want to look at the code line by line.
Oh, okay. So
Yeah.
reason we're using these algorithms such as logistic regression, random forest classifiers, because this is more of a classification type problem. So we need to it's not a regression type thing. So that's basically why.
Okay.
Yeah. Wait, should I carry on?
Yeah. Just carry on with the implementation part.
Yeah. So then we need to over here exclude the columns that are unnecessary using this code over here. and then we have our updated data set that we need that we want to feed to our model. So over here we see that this is a visual I created that shows the employee attrition count, and we notice here that most of like a lot more people have not resigned from their job versus a lot of people have resigned. So main takeaway that I see is that since our data set is unbalanced, there can be some problems with model bias when like our model is predicting with unseen data.
Okay.
So here's another visual that I created. So here we have a heat map showing correlations between numeric features in our data set. So for example, here we see that there's a positive correlation with the number of years with the current manager and the number of years at the company. So we see over here that the more red it is, the more the more positive correlation, and then more blue it is, like the less correlation it has. And then this helps with deciding basically which features we can possibly group together and form a new feature, which is known as feature engineering, which I will get to. And that's basically what this heat map helped me do. Yeah, so now we're getting to the feature engineering step. So reason we do feature engineering is because we want to transform raw data into a format which is easier and more efficient for models to learn. And this improves the accuracy because there's less information that our model needs to deal with. So there's less chance of overfitting. And it also helps us generalize our data if we don't understand the individual features. Yeah, so over here, what I did is I combined similar related features and put it under like one name. For example, here with demographics and here with the job related features. And we see that, like, for example, monthly income, total working years, and employee number are closely related. Uh, and then so we can group them together basically.
Okay.
So here's a visual that I created using that. So blue means yes, there was attrition, and orange means there was no attrition. And then here we see some of the trends. So the people that are younger, they tend to resign more from their job. And over here, if the distance is from home is sorry if the distance is from home is a bit like less, and we see like um that there's less attrition. I mean, there's more attrition over here. Yeah, so here's the visual I created for feature engineering, which helped me visualize. So we see like the lower the monthly income over here, the more employees resign, which makes sense because they're not earning enough money in that job. And as for working years, total working years over here, the more years that experienced employees have, typically the less they tend to resign from their jobs. And so those are basically the main two things that I took away from this. Another feature I created was income per age. So we divided the monthly income by the age to create a new feature called income per age. So this helps us identify basic trends like how income can change with age and highlight different discrepancies between different demographics. Then here I created a histogram or that shows the distribution of income per age. So we see that the lower the income is, like, there are more people with a lower income per age than a higher. which is definitely a big factor when it like comes to like people resigning. Yeah, so now we moved on to model experimenting. So yeah.
Siddhant, quick question. So the feature engineering you mentioned, you only did it over the 10 top 10 columns you chose, right?
Yes.
Okay.
Yeah. So for model building, we started on experimenting with different models on our data, and we decided which model we were going to use. So we first tested out logistic regression, while incorporating PCA for better accuracy. And we see that over here, this is actually a screenshot of the results. We see the accuracy is only 57% with our data. So that's not the best. Then we tried decision tree classifier and random forest. So the accuracy for decision tree was 74%, and for random forest it was 84%. So far I knew that random forest would be a reasonable model to use for this type of problem. And then I tested out XGBoost, and then I got an accuracy of 85%. So we saw that this model was performing the best for this problem, and therefore I decided to go with this model for the application and save this model. So then once we chose our model, which was XGBoost, I chose those decided to choose 9 important features, because I didn't think the other one was as important because of other visuals. So I chose these most important features, independent features for that affect attrition. And then over here I chose and then of course the dependent feature is attrition. And over here I had to convert this into like numerical data, because I was getting some sort of error that said it could not read like the words that the data needed to be converted into numerical data, because our model can only understand numbers instead of words. Then we split our data into training and testing, like shown. So 80% was training and 20% was testing. Then here we chose our XGBoost classifier and we trained it. And then after training was done, we predicted our model and then evaluated it. And then we saw our test accuracy was 84.6%. So it did not perform too well that the model became overfitted.
Sorry, could you
Yeah.
repeat that? You mentioned that the model. Could you repeat the sentence that you
Yeah,
just
so
said?
I was saying our accuracy for testing data was 84%. So it wasn't too there wasn't a very significant difference between the training data accuracy and the testing data accuracy that for the model to be overfitted. So we knew it was not overfitted.
Okay.
Wait, should I continue?
Yeah, continue.
And then finally, we saved our model into a PKL file, so that we could use this model in our Streamlit application, which is basically the website that we create our actual project on. And then this helps us access the model for prediction. And then last step was to create the Streamlit application. So there's not much to say about this. This is just where you create all the features such as sliders, buttons, stuff like that. So it's like creating a basic HTML website. Was the easiest and shortest stage, and then and then the app, and then I'll show a demo of this Streamlit application, since there's not much to talk about for this.
Okay, I had a question that
Yeah.
actually, could you give me an example of a practical application for this?
It could be a form or something that asks for example, different features that affect attrition, and then it predicts predicts whether the employee is likely to resign or likely to stay. So, and it gives the exact percent of what the probability of whether the employee will resign or not.
Okay.
Yeah.
But who will use this form, right? I guess the
Who would
question.
use these?
Yeah.
Different businesses, like for example, CEOs could use this to predict whether like if someone's if like the manager sees that uh that the people working underneath him are if he notices some patterns, for example, people working underneath him under him, they're not attending their meetings, or they're not responding to emails, etc. Then they would probably have them fill the fill have the people fill out the form, and then see, or not have the people, or they would probably fill out the form by
They
themselves.
would fill out the form, and okay, so they would fill out an application to
Yes.
determine with like how the how their team is looking in terms of
Yeah. Basically.
leaving or staying. Okay.
Yes.
Okay, so this would be from the point of view of the HR manager, right?
Yes.
Okay,
For
so this would be on the basis of the observations that HR manager has made.
Yes. Well, if the HR manager just notices some notices some wrong trends with the people working underneath them.
Okay, but I would like to have a question on that. That there might be some in not all cases the observation made by HR manager would cover all the aspects about the employee, right?
Yeah.
So, yeah, I understand that from that POV, you have included many features that could be useful. But I would like to ask you, just as an advancement, what feature can you think of that could include what input that you think of that could include some aspects about the employee from his POV?
Oh, so from the HR manager's point of view, you're asking what features could he see?
No, no, no. Yeah, yeah. In this application, it is the distance from home, the overtime that employee is working, the salary, the time he has
Yeah,
been in the company, and
yeah,
everything like that.
probably the salary, and like how much overtime the employee is.
So I think, Siddhant, they're asking what is the, from an employee perspective, what other features? Is that
Yeah,
correct? You're asking what other
yeah, yeah.
features can be used?
So as the employee resigning,
Sorry.
as
No.
wait, what's your question?
Yeah, I'll elaborate on that more. I mean to say that everything is around from HR managers POV, right?
Yes.
But there's nothing that I see that is about the employee's POV, right?
Yeah.
Because every observation from HR or the manager cannot be deemed accurate in all cases. So if I had to ask you, in the current version, it is not including something like that. But if I want to ask you from your understanding and the implementation that you have made, what can you think of right now that you can include in the future that could also elicit responses from the employee, from his POV, his responses.
Well,
Uh,
maybe I could add like a separate form specifically for the employees, and then keep this form that I made specifically for the
No, no,
age.
but what questions, like what other data would you collect from the employees? Not a different, what other
Uh,
features?
well, Uh, well, I guess like how many. Well, it would be more challenging to like collect data from like the specific employee. Like,
No, assume the employee is willing to share.
Yeah.
well, I guess how like how many meetings the employee has missed, how or something like that. One of
No,
the
that is already there, right, in this
oh,
data set.
the number of meetings is not there. How many meetings they've
No,
missed?
but what else can, like, what will the other like, if somebody's I guess the question is, somebody's unhappy, what other signals will they provide?
I guess like how much like this might not make sense, but like I guess how much they're like whether they're getting enough sleep or not.
Okay.
Yeah, what that could be a feature, an indicate that could probably like be
How, like, how do you say that they're getting enough
like
of,
I guess
how many
how many
holidays
hours
they have, how
they're sleeping.
many have they, how, if they have taken any vacation or not?
Yeah, how many hours they're sleeping at night? How long have they been absent from work?
Uh, the absence and everything can be done by the HR and that.
Oh.
Uh, yeah, I specifically mean to talk about the features that only the employee could.
Only employee knows, yeah.
Yeah. So yeah, how many hours? Like for example, like you said, how many hours of sleep the
Yeah,
employee is getting?
that's
What else?
valid.
That
What
could be.
else? What else?
What else? Let's see.
Only the employee knows.
Yeah, I know. Mm, maybe uh prob probably like how. Never mind that. Maybe I guess how like the how well whether his coworkers are helping him or not, but
Okay.
I think
Yeah,
that's
yeah, yeah. Okay. So that can be,
that
what
could
kind of feature it will be, like cooperative team, like a team
uh,
culture kind of thing.
yeah, team, yeah, a cooperative feature.
Okay. What else?
What else?
Hmm.
Um, probably like uh, probably how much if he's I guess whether he's whether he's getting 3 meals a day.
Okay. So whether so one way of saying is whether they are, like, whether the compensation is sufficient, right?
Yeah.
So compensation satisfaction, something like that, right?
Oh,
Can be a,
compensation satisfaction.
yeah.
Okay. Uh, yeah. Next, yeah. Any should I show the demo now? Yeah.
Just I would like to give one feedback on this.
Yeah.
Yeah, the points that you thought of about the employees POV, yeah, that were really that were valid. But I would like to suggest on that in projects like this, you'd have to take a step back, because in the end, it is something about the employees attrition. This is something related to the employees, right? So
Yeah.
you would have to consider more factors about the employee rather than what the manager is observing. Some factors are valid, but it should lean more towards what the employees are feeling, and like that. A good example would be like, yeah, conducting a good, healthy environment where there are specific departments with that maintain communication with the employees, weekly surveys about things like the things that you mentioned, the how many hours of sleep they are getting. They can compare that. Yeah, this is your overall work schedule. How happy are they, and how much it is affecting their personal lives and everything. These are some more things that you would have to include in this to actually make it very practical.
I see.
Yeah, your direction is right. Really like your direction, but you'd at this point, to just take it to a next level, you'd have to just take a step back and understand that you have to put more efforts on the employee's POV and find more ways how the employee can be engaged with that
Okay.
in a way that he does not feel that. One more thing that you would have to keep in mind, that the employee should not feel that, yeah, the company, the managers, the HRs are doing something for their own benefit. They should also feel included, that yeah, the companies actually uh, the people senior to me care about my life.
Okay.
That should be something taken care of. Yeah.
Okay. Okay. That makes sense. Should I give a demo?
Yeah.
How do I close out of this? Uh, yeah, we'll give. So yeah, so over here, we have this is basically the form that we see. So you have these factors: age, total working years, monthly income, daily rate, overtime, job level, distance from home in miles, and the monthly rate and the hourly rate. So if I ask it to predict, let's say, then it shows whether employees likely to stay or not, and then it shows probability of resignation as 5.19%. So you can let me know what you want me to toggle and what features you want me to add here.
Uh, change something regarding his age, maybe decrease his age and increase the working hours.
Okay,
Working hours.
working hours. Okay.
Haven't you included something related to working hours?
Working years.
No, 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 not working years. His working hours, daily working hours. That would be something that's really important.
Uh, yeah, I could have included that. My bad.
Yeah.
Sorry.
Okay. Yeah. Because I think when you consider every feature, his daily working hours would be something that's really important. One of the most important features.
Okay.
Okay.
Yeah. Anything else you want me to toggle?
Yeah. Just tweak some outputs and just show me the prediction result.
Oh, yeah. Change that if I do this.
Okay. Is the employee number actually affecting this?
Uh, well, not really, to be honest.
Okay. Because yeah, you did some research on the correlation and yeah. Okay. Okay. It's okay. Yeah.